right, so we're going over our Unit 3 study guide. The unit test for my B day students is this Friday. If you are an A day student, your test is Monday. So that means you should definitely study over the weekend and not think that you don't have anything to do. 15 minutes a day. And all week, right? Monday, tonight, 15 minutes. Tuesday, 15 minutes. Wednesday, 15 minutes, right? It really won't take that long. Okay, so heat transfers, 5 to 6 questions. We still have the water cycle on there. This is about 1 to 2 questions. This may be slightly off because I'm just going from memory, but just bear with me here. 1 to 2 questions. Actually, it'd be more like 3 to 4 questions, but that's okay. Weather variables, I'm gonna say is about 4 to 5 questions. And then we've got natural disasters, I'm also gonna say is about 4 to 5 questions. Your test is about 20 questions total, I think, around there. So I might have, some of these may just be one-off questions. And then last but not least, turn it over to the final back page, the atmosphere. So actually it's like, I think it's like 23 questions. I can double check today. The atmosphere is about 4 to 5 questions. So you have the most questions on heat transfer, and then you have about 4 to 5 questions on every other topic. I am bringing up the water cycle again because it is something that influences weather, right? So now that we know about the water cycle and about weather, it's more about talking about how those two things are related specifically, okay? Now, if you're a mobile student, I just want to show you a way that you can write on this if you do not have a printer. So here I am in Schoology. I'm going to go to my courses and I'm going to go to our class. You'll see that the study guide is up here. It's not due until the test day. So I'm not asking it to be submitted until the test day, but if you finish it early, that's fine. I can also access it by looking at Unit 3 and going to the folder for today, February 1st. So the only things that we have for this week is the do now from today or do meow from today and the study guide, because you guys know what happens on Wednesday, right? All right, good. Our review day. So, and then Friday's your test. I'm very excited. You won't be here Wednesday? Oh. I might in the morning need some assistance from a couple of you, but I'll talk to you later. Okay. Anyway. All right, so my mobile friends, you can go ahead and click on the Unit 3 study guide. It'll come up at the bottom page, right, or the bottom of your page right here. And it's going to open up Microsoft Word. When it opens Microsoft Word, it's going to have this button at the top that says Enable Editing. You won't be able to type on it until you hit Enable Editing. Once you do that, you can type on it. Just like that. However, what you need to make sure that you do as a mobile learner if you're not printing this, is to make sure you save it, file, save as, and save it in a place where you know you keep all of your science stuff. So I might browse to where I want to save it. If I have a folder specifically on my desktop for all of my science things, I can save it there, but you could put your name and the study guide. So there should be no reason that anyone shouldn't submit this, because you could either print it or type on it. And especially now that I showed you, and if you forget, you can always watch the YouTube video for guidance on how to do that again. All right, so we're gonna actually go through and do the whole thing together to make sure everybody has it right. Yes. All right, if you did fill some out already, absolute kudos, right? But I wanna make sure that you have the same thing that I have, because, and I know we've gone over this before, if I have something on my paper, I can guarantee you that there's a reason it's on there, right? Maybe a trick or a hint, but I need everybody paying attention. Okay, because this is your test, not mine. Again, you probably heard that like 1,000 times. All right, so if you miss anything, go ahead and check out the YouTube channel. This is also on my website, dcsmscience6.weebly.com. You can also Google Miss Burley and I'm up there. Here's a blank copy, and then here's the completed copy. So it should look as complete as this by the time that we are done. It is a lot of writing today, but it will be worth it. It will be worth it. Okay. Oh, I realized that on the paper, I put direct contact because I thought it said conduction. So my apologies. Correction. So this is convection, not conduction. So when I typed direct contact earlier, that was a mistake. And this is just proof that teachers make mistakes. All right, so what should I be writing for convection? What should I be writing, Caroline? Yes, this is heat transfer through liquid or gas. Through liquid or gas using currents. What happens to hot air or liquid? Does it go down or up? Ethan? Yep, hot rises, cold sinks. Hot rises, cold sinks. Give me some examples. We talked about one in our Do Me Out today. Emerson. Okay, so a hot air balloon is a good one. And keyword is air, right? Ethan? A what? A pond or a pool. So when so I could just say, I'm gonna say a pool or even the ocean, because that's why it feels warm on the top but cold at the bottom. Brennan, give me an example. When you're cooking, give me an example of convection when you're cooking. Boiling water, very good. What when I'm boiling that water, what also happens as a result that is an example of convection? When I hold my hand over the pot. What do I feel? Bishop? Yep, steam, right? What was the one that we talked about in our do now though, Caroline? Earth's interior, very good. All right, I'll let you catch up. We got lots of good examples. If next time I type something wrong, just call me out. Call me out and let me know. The angle from my desk to the screen sometimes makes it harder to see when I type. And we remember that the C stands for current, the V is like an arrow, and the T is like an up arrow. What's conduction? Remember, I have my D and my C. This is heat transfer using what, Brennan? Direct contact, very good. So when heat moves through direct contact. And I use the word moves this time to just remember that transferring something is moving. When I transfer schools, I've moved schools, right? Hopefully no one transfers schools. I want all y'all to stay. So heat moves using direct contact. Yes, love. Okay, yeah, give me an example. Touching an iron? Okay. I'm gonna say touching anything hot. Yeah, when you burn yourself or touch anything hot. This even includes when you burn your tongue on hot coffee, or when I cook in cast iron, and so like cast iron is a really great conductor. So if I touch the pan at all, I will burn myself. Or when you have hot soup and you have a metal spoon and the spoon gets hot, right? So literally touching anything hot, whether it's you touching something hot or something else touching something hot. Give me another example. This can be one of my mobile friends. I want an example from my mobile friend. Somebody give me an example of something that is heated using direct contact. Think about the brochures you submitted.
Stove.
Very good. So a pan on a stove. It's directly touching that burner, right? There's my burner and there's my pan. It's directly touching. And then I don't want anyone to put anything in a fire necessarily, because like if you put roasting on marshmallows, some of you are crazy and like burnt marshmallows. I don't know how that works, but it's okay. I like burnt hot dogs, so yeah, it's weird. But if you have something in a fire, that's conduction. Over a fire would be radiation. Very good. How many of you go camping? Okay. I go camping, and there's some really good desserts that you can make by putting, if you put a banana and you take one side of the banana and you unpeel it and you put chocolate on one side and marshmallows on the other, put that peel back and wrap it in tinfoil and you put it in the coals. So it sits in the coals of the fire. What would that be an example of? Conduction, because the coals are touching the food, right? You do the same thing if you take an orange and take the inside of the orange out, like cut just the top of the orange, take the inside of the orange out, put a cinnamon roll inside, put the top back on, wrap it in tin foil, and put it in the coals for about an hour, and you've got like an orange cinnamon roll. Yeah, super good. Also conduction though, because it's touching those hot coals. All right, and then radiation. Rays, very good. Does this involve touching? No touchy, very good. So this is when heat transfer without touching. Using electromagnetic waves. And or rays, remember, because that's what our R stands for. Jordan, please check the chat. All right, what's the biggest example in the entire universe? Call it out. That you didn't say it very fun. The sun. Yes. All right. I know it's Monday, but come on, y'all. Mondays, it's all about the way you look at it. Mondays are a fresh start, a new beginning. And if you had off on Mondays, then Tuesdays would be the new Monday. Either way, there's a day where you got to get started, right? Everybody's got to get started. I put the sun, but I put a star there because it's the most important. It's literally the one that drives the entire Earth. Without the sun, we would probably be pulled into the gravitational force towards Jupiter, honestly, because it's the next biggest planet, or it's the next biggest thing. The sun is a star, not a planet. But we would also maybe turn into mole people. Yeah, because there'd be no sun, so there'd be an ice age on top of Earth, and the only way we could keep warm was to try to insulate ourselves by digging deep holes into the Earth to try to stay heated as close to the Earth's core as possible, which would be very difficult. And then we would have to learn over generations and generations and generations to see in the dark as our, bodies adapted over time, and our skin would become very pale. And yeah. I've thought about this a lot, actually. We would have to live off of dirt. So that's why I get so excited when I say the sun, because it's like those guys in Toy Story. Yes. It's like the claw, like the master of the universe. What's another one? It's a way that we cook, and it literally has the definition in the word. Somebody new. I'm looking at somebody who's not paying attention. Strike two. Christian. Hey, buddy. What do we cook with when we're in a rush? And it literally has the word in it.
Fire.
What is it?
Fire.
Fire. Okay, fire is a good example, but don't always have time to cook with a fire. my coffee got cold and I'm gonna reheat it in the
Microwave.
microwave. My coffee got cold. And then also, what else do I cook with? A stove is touching. So what part would be the radiation, Caroline? A toaster, or think bigger. Air fryer would be an example of what? Air. Convection. Think bigger. I gotta make a casserole or a lasagna. Where is that going? The oven. Very good. Like, we need to have a cooking class. We're gonna have a cooking class up in here. Huh? All right. Oh my goodness, look at this. This is basically our do now, guys. And if it's on the study guide, it corresponds exactly to questions. Like when I made this study guide, I had the test right next to me. And you know that I put all the questions or topics in order, like I chunk them, right? So that you can use some to help you with others. I do it very strategically because I want you to be successful. And when I wrote the study guide, I had the test right next to me. So it means that everything that's on the study guide is purposeful. It's the first 5 to 6 questions. All right, how is heat transferred inside of Earth's interior? We already talked about this. What is Earth's interior made out of? Liquid metal! Like metal? Oh. I'm trying to get you guys to wake up. Liquid metal, okay. So if it's liquid, keyword liquid, it is convection. It says liquid. What about from the sun to earth? Look at you, so eager. Radiation. Ooh, ooh, ooh. Who thinks they can answer this one and tell me why? Who thinks they can answer this one? How is heat transferred in ocean water? And tell me why. Emerson? Because? Very good. Water is liquid. So we know that there are currents in liquid. There's also ocean currents, right? That has to do with density and wind but we also know that heat is transferred in liquids using convection. Again, the same reason why you get deceived when you go to the pool and you get your toesies in the top and it's like, you're like, oh, that's not so bad. And then you jump in and you're like, oh my gosh, that was so cold. The deeper you go down, that's happened to me. Yeah, and all that cold water sinks because the molecules are denser. They're more tightly packed. Like when we get cold, how we like get all tightly packed. Yeah. The water molecules do the same thing. Don't be fooled. We know better. Science has taught us better. All right. Let's think about this. Which process of the water cycle? So we're back to the water cycle here. We're talking about condensation, evaporation, transpiration. runoff, precipitation, all the Asians, right? Which one is directly affected by the warming of ocean water? So which one happens because the ocean gets warm? Brennan, evaporation. Very good. He like lit up. Evaporation. Because the sun heats the water, and then the molecules get all excited, and then they speed up, and then they spread out, and then they rise and turn into a gas. And then what happens when they get to the top of the atmosphere? Okay, they condense because they get colder, right? And they form clouds, which in turn forms rain. Very good. Very good. What? Huh? All right, how we doing, my friends, my mobile friends? All right, good. Remember, in case you miss anything, this is also on my website, and it will be on the YouTube this afternoon. The YouTube. All right. So this question may seem a little weird, but I'm going to explain to you. How does nearness to the ocean, so being close to the ocean, right, affect precipitation amounts and temperature? So how does being close to the ocean, think about this in terms of Florida, right? We right on the water, affect precipitation amounts and temperature? What do you think, Carlos? All right, so think of, we just talked about weather variables last week, right? What what weather variables are going to be directly affected by the nearness to the ocean? The amount of rain, very good. So if you're close to the ocean, are you gonna get more or less? Why? Why? Ethan? Yeah, more water to be evaporated. And because we're close to, in Florida, we're close to the equator, how does that impact it? Caroline? Makes it more humid, more water is going to be evaporated into the air, right? So if you're by the coast at all, like remember I said I grew up in Baltimore, Maryland, right? Right on the Chesapeake Bay, not close to the equator at all. It actually gets pretty cold. It's snowing there, I think yesterday and today. But it's still evaporates. The water's still going to evaporate, but it's still humid because there is water to be picked up. Whereas like in the Midwest, and you're not really near any water, it's more of a dry heat where you don't feel that water in the air. So the closer you are to water, the more humid it is, and that means more water in the air, right? Which means, what does it mean? We just said it, but what happens to precipitations? Yep, more precipitation. What about temperature? You think so? Slightly cooler temperatures, right? Because like the water's cooling things off. And we get something called a sea breeze. Have you ever been close to the ocean and it's like breezy? Mm-hmm. Absolutely. Yep. Good memory. Mm-hmm. And if you need to, I'm going to write this just because I want to get as much information as I can. Closer to the coast means more water to be evaporated. There's more, literally more water. Y'all are doing good. You will have everything you need to be successful by the end of this class period. Thumbs up when you're ready. I take water. Can you believe that this was dinosaur pee at one time? Yeah. All the water that's on Earth has been here for all of time. Yeah, that's right. Yeah. Huh? I do. I do. See? I don't have as many this year. All right. Flip it, but don't rip it. What does a warm, moist air mass over the ocean most likely cause? If it's warm, it means it's going to evaporate. And if it's moist, it means it's humid. So if there's warm, wet air in the atmosphere, what is going to happen? What do you think? Warm air, right, means evaporation. It's evaporated and it's wet. Eventually, what's going to happen, Bishop? It's going to rain. Evaporate, condense, precipitate. And repeat. For this next question, what is the driving force of the water cycle? What do I mean by driving force? Caroline? Yeah, what causes it? The sun. Say it with me. The sun. Anybody? No? Okay. Thank you very much. The sun. And look, I'll even draw a little Toy Story guy. Just little me with the men. There we go. Huh? All right, look. Then you fix it on your on yours. They have one. I know. I don't have, or now I know. But in my head, I was thinking too. All right, what causes wind? This was in our weather variables notes. This is, again, definitely a test question. If you need to get those notes out, get them out, get them out. I'm not going to tell you what causes wind. What causes wind? Ethan. No, what about air pressure? What about air pressure? Very good. So the fact that there is a difference in air pressure, it's like trying to fill a void. So the difference in air pressure, I'm not kidding, this is a straight up test question right here. The difference, thank you for those of you that referenced your notes. The difference in air pressure. Today was super windy. It was moving from areas of what kind of pressure to what kind of pressure? No, remember what I said about the alphabet? High to low, right? Because H comes before L in the alphabet. H comes before L in the alphabet. Yes. It was super windy yesterday. And this morning too. I was running downtown on the bridges this morning, and it was like trying to go up that bridge with all that wind. It's pretty. Yesterday was super windy too, though. Tied a onesie for me, like one of the baby onesies. Not for me, like a baby onesie. Yeah, not for me. That's weird. Yeah, not one of those. I'm talking about like little baby ones. So weird. All right, moving on from the weirdness. We just said that wind is the movement of air caused by a difference in air pressure. So that's what we're gonna write. We're defining them, and what we're gonna write what they're measured with. Because on the test you need to know both. Does anybody remember what wind is measured with? Think about the tornado. Think about the trick I taught you. An anemometer. That's right. Anem. It's really pronounced an anemometer. But if that's what helps you, go for it. There's our anemometer, right? And this is the movement of air caused by a difference in air pressure. And it makes sense that it's air pressure because isn't wind literally just air? And we're going to write that it's measured with an anemometer. Anemometer. I was in Palatka this weekend, like I went to this really cool state park, by the way. Y'all should check it out. It's called the Ravines State Park. Super pretty. There's a park. It's super pretty. But anyway, I was in an area close to there afterwards with Mr. Johnston, and we were on this dock, and he saw an anemometer, and I told him about the trick that I taught you, and he goes, "Anem," and it warmed my heart. We're such nerds. I'm proud of it. All right, humidity. What is this? What is humidity? Hey, girl, I haven't called on you yet today. What's humidity? Exactly, the amount of water, vapor, or moisture in the air. I am going to check your gizmos, by the way. The online lab that we did the other day. I'll check them in a little bit. I didn't forget. My 8A students didn't get to do it, remember, because the internet was down on Friday. So when you're done writing, just get them out. And that way I can just go over and just look at them quickly. I might even ask you to put them on the table as you leave, and I'll give them back to you. Huh? I just don't want to forget. Don't give it to me right now, but just hold on to it for a sec. All right, relative humidity is always in what form? What does it look like? It's a percentage. Very good. It's always a percent because it's relative to temperature. This is the amount of water vapor in the air relative to or at a certain temperature. So the amount of water vapor in the air based on temperature. Ooh. Who remembers which can hold more? Cold air or warm air? Which temperature can hold more water vapor, warm air or cold air? Think about our cups. Think about our cups. Wendy? Warm air, very good. Our red cup could hold more water. What happens if it, quote unquote, overflows? What does that mean in terms of weather? Christian? Rain or dew, right? It'll leave little dew on the ground. Nice. Air pressure. Who thinks they can tell me what air pressure is? My mobile friends. One of my mobile friends, tell me what air pressure is. Think about literally what the words air pressure are. Oh, we forgot to write what this is measured with. Does anybody remember a relative? No, well, a barometer for air pressure. But does anybody remember what relative humidity is measured with? Hygrometer, or it's also known as that's what crazy people call it. No, that's blood pressure, but a psychrometer or hygrometer. Well, you guys were absolutely right, which makes me so proud. Air pressure is measured with the barometer, like bike pressure or blood pressure. But I'm still coming back to my mobile friends. Y'all, what is air pressure? Tell it to me. Think about the words, guys. Come on. I want you participating. Use your notes from last week. Caroline. Literally pressure from the air. It is the amount of force or pressure, right, that the air puts on something. The amount of force from the air. My mobile friends, I need you guys participating in class. I'm going to super simplify that and say the amount of force from the air. Remember, the air is constantly pushing on things, right? Blowing things, like us while we were trying to walk into the building today. But I'll simplify that because it's the amount of pressure that we feel from the air. Air temperature. Don't just tell me how hot or cold it is because we're beyond that as scientists. 6th grade scientist. So what is air temperature? It has to do with a certain kind of energy. I love that I see people referencing their notes. Carlos? No, try it. It's the amount of what kind of energy? You said what kind? That's okay. Let's, Mazzy. Kinetic, very good. It's the amount of movement or the amount of kinetic energy in air molecules. Measured with a thermometer. Therm means hot, right? If there's more kinetic energy, what happens to the temperature? It goes up. Very good. Think about when we were rubbing our hands together. Less kinetic energy, it goes down. Like when you're frozen and you're not moving at all. Very good. Now, I know we didn't like explicitly discuss droughts because we don't experience them here in Florida. We experience quite the opposite. We're gonna talk about what causes droughts and how we protect ourselves, because remember, we can't prevent a natural disaster. They are naturally occurring. However, protecting ourselves from a drought just means being smart. What is a drought? What is a drought? Brennan? Very dried out. So it is an extended period of time without precipitation. And I think I told you guys about this. When I was over the summer, I was camping I went Oklahoma to New Mexico to Colorado, and I was just camping along the side of the Rockies, okay? And you can camp just like on the side of the road. Like they have sites or whatever and they're free. It's super awesome. But you're in a bunch of national forests while you're driving on these roads. And they had signs along the campsites that said no fires. Not because you're in a forest, but it said at this time there are no fires because it had not rained in a while. So they were afraid that what would happen if I lit a fire? What were they afraid of, Ethan? Yes. Very good. So this is the reason that I wanted to put this on the test, because it does reference this. This can cause a wildfire. Actually, I believe that the wildfires that were in California earlier this year were started by a match because it was so dry there. California is very dry. So it can cause wildfires. It's super dry. Oops. That's weird. Yeah. Sorry. I was just doing that for fun. All right then. Next page. Now you guys should remember natural disasters from our presentations. This was before break, right? Okay. We know a tornado is a high funnel of a funnel of high force wind. What do we do? What do we do to protect ourselves? Do we go to high or low ground? Very good. Sorry. We go to low ground. We build storm shelters. What I need you to know, and this star over all of these, for every single one, we build out of stronger materials, like the big bad wolf, right? He's not going to blow my house down if it's made out of bricks. So to protect ourselves from every single type of natural disaster, we want to have alert systems in place and build with stronger materials. Now we know a hurricane has to form over warm water. And it's a well, so not always fast moving, but it's a cyclone filled with wind and water, right? Bless you. Cyclone of wind and water caused by a difference in air pressure. Are we going to go to higher or lower ground? We're going to go to higher ground here. Bless you. And as always, have alert systems built with stronger materials. We might even have storm shutters. You might notice roofs in Florida, our roofs are A-framed. Have you noticed? So water can flow down the sides. If it's flat, what's going to happen? The water's going to pile up. Very good. So we build very strategically. What's a tsunami? A tsunami. Oh, what does tsunami mean? Does anybody remember what su and nami means in Japanese? What is it, Emerson? It means harbor wave. This is a large wave caused by an underwater earthquake or volcano. High or low ground? High ground. You do need to know that it means harbor wave. Yep. 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 What causes an earthquake? What causes an earthquake? Ethan. Tectonic plates. Tectonic plates shifting and breaking Earth's crust. For this, we just need to build out stronger stuff. Floods. This can be caused by hurricanes, thunderstorms, and it can cause, I need to tell you this, it can cause an increase in disease. Water, that water can carry diseases because it's nasty, right? It's not purified. It's all that stuff coming from the ocean. And if you remember the documentary, you weren't here at the time, Ethan, but in Hurricane Katrina, they had dead bodies floating in that water, people waiting to be rescued. And sewer water, very good. So it's important to store clean water. Have an emergency kit. Bless you, bless you. We're so close, y'all. Yes. All right. How do we protect ourselves from excess or a lot of sun exposure? This is a test question that I really want to make sure that we go over it. What do we wear? All right, so we wear sunscreen. So we wear sunscreen with a high SPF. What do you see babies wear at the beach? And like the surfer shirts, right? All right, look, higher sunscreen SPF means more protection. Actually, it means sun protective factor. So the higher it is, the more protective it is. But if you want to be the most protective, not only are you going to wear sunscreen, but you're going to wear long sleeves, pants, and a hat, because then your skin isn't even exposed to the sun. It would be very hot, but there are some people who are at a very high risk to develop skin cancers. Some people have very fair skin and get burnt very easily. And so you'll see certain people who know that they can't handle the sun. They love the beach, but they wear long sleeves. I always pack something with long sleeves in case, I like to read on the beach. So if I fall asleep and then I realize my back is toasted, I put long sleeves on. Yes. Yeah. Yeah, the sun kick, that's why it's super important to stay hydrated. All right, I want to flip to the back really quick. What gas is gas A? 78%. 78%, Christian. Nitrogen. What gas is 21%? Mazzy. Did you see I made that a Q? What is happening to me? Oxygen. And then the other 1%, other gases, such as carbon dioxide, water vapor, cal farts, etc. And then for this part with the layers, y'all, last part. Last part. They'll insulate our planet and keep us warm like a blanket, right? Oh, cute little blanket. But how do they protect ourselves? What does the troposphere give us? Weather, very good. Without weather, no water, no life. Stratosphere protects us from those, fights those UV rays, those ultraviolet, violet rays. What does it have in it? Very good. The mesosphere. Very good. Protects from meteors. The thermosphere. This one protects from, very good. Remember, thermo means hot. So this is where your hot grandma lives, and she's going to get an x-ray. Yeah. So protects, it protects your grandma. Not really, it's gamma, right? Hot grandmas get x-rays. Whatever, man, it works. It does. Thermo means hot. Gamma sounds like grandma. And what do grandmas do? They break their hips and they have to get x-rays. It's true. And then the exosphere. Exo means, yep, this is our outside layer where there's no matter. That's it, y'all. You need to study this. Just completing the study guide is not enough. How many minutes a night are you studying this? 15 minutes. Remember, Wizard tournaments on Wednesday. If you and your team want to be on top, earn that homework pass or chocolate bar. It depends on which one you want. For the Wizard tournament, if you win, if your team wins, you get to choose between either a full-size chocolate bar or a homework pass. So make sure you study. You've got the vocab parts of the Wizard tournament. Then we've got our Kahoot, and then we've got our final Jeopardy. So make sure you're ready. Got it? All right. And remember, YouTube or my website if you feel like you missed anything. Study hard, y'all.